Hello, it's Elixir Code Girl here, and welcome to the second series of running code concurrently in Elixir. So, in the first series, I had taken you through what concurrency is, explained the difference between synchronous and asynchronous code, and also briefly explained how to run a concurrent code with a task module. So, in this series, we are going to explore a task module function that can be used to start a process. So, for the function responsible for retrieving the result from a task and shutting down a task will be discussed later in the next series. So let's begin. So today I'm going to briefly talk about the task.start function of RT1. So this function is responsible for starting a task, and usually it does not return the result of the function executed. So how does it work? So the task.start function takes in an anonymous function. So remember, this anonymous function must have a zero arity. Then you can do anything within that anonymous function. Then it returns for you a tuple of an atom, okay, and a PID. So the PID in this case is a unique identity of the process that has been started. So let's jump to the text editor or interactive shell and see how the task.start works. So I will start with a simple example here. So let's start our task. I want to pattern match because I want to use speed later on. So I'll give it an anonymous function with a zero arity, then tell it to execute the process that the task that I'm giving it to. So I just want to output a simple statement. I love exploring. I like to make coding fun by writing things that makes me happy. So let me run this. So if you run this, you can see our message, I love exploring, being outputted immediately. And we have an OK and a PID. So it has completed its task. So what happens when a task completes what it has been subjected to do? So let's see what happens to this process. So I'm going to use the process.alive and give it a PID. So we can see that the process has already been terminated. So whenever a process is started or whenever a process is running, that process must be allocated a memory space. So with task, we can see that the process has been terminated after it completes its task. So this can be this is advantageous to us because there's no at one point would like some idle process occupying the memory space while they can be removed. So the fact that a task terminates that process is an advantage when you're working with them. So let's see another good example we can use to validate that process terminates after task is completed. So this time round, I want to run to send a message to different numbers, and each message will have a delay of like 60,000 milliseconds. Yeah, so 60,000, I can reduce this to 30 because 60 is a lot. So I'm going to use the previous example I used to demonstrate how to start processes concurrently. So let's see how this works. So I'm going to call this. Let's do the task. So I want to use the task later on. So I will give it a variable task. And what I'm going to call is the notify all synchronous. So how does the notify asynchronous work? So you give it a list of numbers. It will turn it through the list of numbers and start a process for each number, for each for each task of sending a message to the number. So I'm going to call notify all asynchronously and give it a range of numbers, maybe 1 to 5. So I already have a variable, so we're going to use this variable later on to demonstrate how the processes are being handled. So when the process is running, I don't expect the process to be terminated, but when the task is completed, I expect the process to be terminated. So that's it. So I'm going to call this function here immediately. I had to write it somewhere so that we can test it. The process is still alive. So let's give it like some few seconds for it to be terminated. It will only be terminated once the task has been completed. Okay, so our task, the task has been completed, the process has been terminated as well because we don't have a live process. Okay, so the next step is what happens when an error occurs when the task is running. So I'll clear this first. Let's say a simple example. Okay, kid. So I want to deliberately introduce an error. So we have the task.start. Let's give it an anonymous function, the zero arity. Then do a sum, a simple sum with a number and a string, which will automatically raise an arithmetic error, but I want to see how our task will behave. So we have our task returning okay PID. So it's very easy for you to miss out this error because remember the task.start does not return you the value. So you might miss this error very easily. So for example, in our example, which you are sending the messages, in such a scenario, I would advise you to capture those error or save it somewhere. In the case whereby you might want to know what has happened to each of the tasks that was being started, or even you might want to run a cron job later in case that an error occurred. Okay, so in another example is I want to start a process for running a bunch of tasks at the same time. So one process running a bunch of tasks and introduce an error to that bunch of tasks and see what happens. So what I will do is let's start a task process. Remember it's Taylor zero arity function, then have an enum.map. I want to, so our task will be simple, adding up these numbers, a range of numbers. So in this example, I want to start a bunch of tasks in one process. So I'll give it a range of numbers that is 1 to 3, which will iterate through and add them by 1. So in this range of numbers, I want to check if a number equals to true. You can choose any number, not necessarily true. So if a number equals to true, I want to introduce an error for that number by taking that number and adding it with a string. Else, otherwise, if for any other number, it will successfully do the sum. So I don't expect an error for any other number. So we can say the sum is, interpolate that. So this is a happy path for us. Just want to be careful with the closing, ensuring that nothing has been left behind. Then end that as well. Okay, so here is the thing. So we can see that the first element in the range of numbers was added. So that is 1 plus 1, the sum was 2. So for the second element, we introduced an error and it has raised an error. As you can see, the arithmetic error. So once an error was raised, we can see that the process terminated and the third element was not processed in this case. So that means if an error occurs while a task is processed, the next process will not go through. The next task will not be completed. So this what I can say with this is that if you have a bunch of tasks to be performed, it might be, better to isolate those tasks into different processes instead of doing that bunch of tasks in one process, because we can see what is happening. So one item has been processed successfully, while an error has been introduced in the middle, the other task hasn't gone through. Okay, so let's see what happens if we isolate the process, if we isolate the task into different processes. So we are still using the task.start here. So in our case, I'm going to do enum.map to enter it through each of the elements. So the same thing, a range of 1 to 3. We have a function, do task.start, function with 0 arity. But there's something that I forgot to do, so I'll just delete this. So I want to introduce an error like before. So if a number equals to 2, I don't know why 2, but for 2, do task.start. Then we can try to add that number to a string, just deliberately introduce an error for that number. So we are done with that. Then else, this is the happy part. So we are going with task.start, the function. You can IO put as well. That's so that we don't miss what is happening. Interpolate that. So do x plus 1 plus that, to close like that. Then let's end our task. Then end the inner map function. Yeah, something is wrong. So I need to rectify that. So something has been left out. So but x plus 1 looks like a function call. Okay, so but there is a variable named x. So if you want to perform a function call, use parenthesis x plus 1. So if you, okay, so I've seen where a problem might be. So I need to add space in here. Okay, that's quick. So here we have the sum of, so 1 has been added. The number 1 was added, the number 2 raised an error, and the third number was added as well. So here we have 3 processes, but one process is the one that raised an error. So that means you can isolate your task, and an error in one task will not block other processes from taking place. So that's it from this short series, and welcome back, and look out for the next series.